Hi everyone. In this video, we continue our exploration of AWS Strands Agent toolkit to develop the agent by AWS. And in this video, we will discuss in depth the anatomy of the agents. So the agents originally appeared because large language model can answer questions, but an agent can do things. So large language model is just a text generator, and it cannot take any actions, although it can reason in very detailed manner which steps to take and which sequence this step should follow. However, it requires additional code to wrap around LLM input and output, which will allow to understand what actions are required to be taken on the basis of the response generated by the LLM. And this code wrapper is exactly the agent. So the agent is organized in the form of the agent loop or agent lifecycle, which makes it exactly possible to run the actions or the tools. So then model receives a request it cannot fully address with its training alone. It needs to reach out into the world. So for example, read files, query databases, call APIs, execute code. The agent loop is the orchestration layer that enables this. It manages the cycle of reasoning and action that allows the model to tackle a problem requiring multiple steps, external information, or real-world side effects. So what is this agent loop? Here on the diagram at the bottom, you can see that originally we have input and context, which is sent inside the agent. So this area is the agent. This input plus context lands the LLM, and LLM does its reasoning. If there are tools defined within the agent, LLM will check if either of the tools defined are applicable for the request or user input. And this way, it will select a particular tool. Now, once the tool is selected, we need to extract a particular tool call parameters, because tool is just another Python function, which is defined with a tool decorator or out-of-the-box tool defined by the AWS development team. So that requires parameter. This is also done by a large language model. Once the tool is selected and parameters are defined, we can now run the tool, and after the tool execution, we will get a response back to the LLM. If LLM decides it reached the goal, LLM will quit this tool selection, tool execution loop, and LLM will generate the final response, which will be provided to the users. So in a nutshell, this is how the agent loop works. In my previous videos, I have shown how AWS Strands Agent can work with vented tools or tools defined by the AWS development team. Also, we have explored how agents can use various LLMs. So in this video, we will concentrate on this agent loop in order to understand how can we intercept each and every step of this loop in real time. And the mechanism to be able to do so is named hooks. So hooks are composable extensibility mechanism for extending agent functionality by subscribing to events through the agent lifecycle / agent loop, the one we have just discussed. The hook system enables both building components and user code to react or modify agent behavior through strongly typed event feedback. So what can we do with the hook? So the hook system is a composable type-safe system that supports multiple subscribers per event type. And hook event is a specific event in a lifecycle that callbacks can be associated with. So a hook callback is a callback function which is invoked when the hook event is omitted. So hooks enable use cases such as monitoring agent execution and tool usage, modifying tool execution behavior, adding validation and error handling, monitoring multi-agent execution flow and node transitions, In this video, we concentrate only on the single agent, hook callbacks, debugging complex orchestration patterns, and implementing custom login and metrics collection. So the basic example would be we have to import from Strands agent class, and we also have to import Strands hooks. And here we define exactly the hook events which we want to subscribe to. In this particular case, before invocation event and before tool call event. Next, we define our agent. We define the callback function, and then we subscribe our callback function to the event by using agent.addHook. So the first, we provide a callback name, and then we provide the before invocation event. So here I have to provide one correction. In the latest version of AWS Strands SDK, this order is vice versa. First, you have to provide the event. Next, you will provide your callback function. So then you can add the second callback function and subscribe this callback function to the event in the same manner. Now, how the hook lifecycle works, and within a single agent, what are different hook events? So this is very important to understand the sequence. As in the agent loop, we have input and context. This corresponds to request start events. In this particular case, this event is before invocation event. This is before agent has been initiated. And this event is followed by the message edit event. So whenever the text is inputted, either by the user or by LLM, this message edit event will be generated. Now, once we receive the request, which is our input and context, it is time for the model events. There is a before model call event, which happens before the prompt is invoked by the LLM. And after model call event happens once LLM generates its output. Again, this is followed by the message edit event, because whatever generated text provided by the LLM, it will go to the general chat history and it will generate message edit event. If during the reasoning LLM decides to use the tool, we will have tool section of the events. So the first event before tool call event. Next, after the tool is executed, after tool call event takes place, and whatever message is added to the general chat, it will be catched by the message edit event. And finally, if agent loop is completed, we will send our response back to the user, and so this is characterized after invocation event. So before and after invocation events, before and after agent invocation events. Then we have model section and tool section. So this is the anatomy of the hook events. Now let us see the simple example of selected hooks. So in this case, I will import AWS Strands Agent. I will select after model call event, after tool call event, before model call event, and before tool call event, and also the message edit event. Also from Strands models, I will input Bedrock model. I will input tools from Strands. This is our decorator to define the custom tool. And also from Strands tools, I will import calculator. Let's now define our custom tool. So our custom tool is getWeather. Here we provide a location, and basically everything what tool is doing, it's returning a phrase with our exact location, but this is a fixed message. Also, we have to define this document string, which is helping LLM to understand what tool is doing and whether or not this tool should be selected. Another helper function to define is message to text. Whenever we get the message, which is registered in the general chat, this message may have various keys. So within the content of the message, we might have a text key. We can have a tool use key in the case of tool selection. In the case of tool execution, it will be tool result. And in all other cases, we can simply get the content of the entire message. Now, let me print the model. We're going to use Amazon Nova model. And here I define Bedrock model as Bedrock model class. We will use US Amazon Nova Pro version 1.0 with temperature 0.3 and streaming true. Now let's define our agent. So we define our agent instance. Our model will be Bedrock model. We will use two tools, get weather and calculator, and our system prompt will be you are a helpful assistant with access to tools. Now, as we discussed about the hooks, we will have to define the callback functions. In this case, we need 5 callback functions as we have 5 different events to subscribe to. So first is on message edit. This happens whenever we have a message produced by the user or by LLM. So this is a callback for all message edit events. In this case, the input parameter is event of type message edit event. Here we will extract the role, so who is basically speaking, and we will print out the which message is added, provide the role, and show explicitly message content. Next, on before tool call. So this callback function will happen exactly before the tool invocation, and here we simply show which tool we are going to use. On after the tool call is our callback function for after tool call event. And here, if the tool call was failed, we will provide such a message. If tool call was successful, we will provide the name of the tool and we will show the result. Next, on before model call. So this is our callback function for before model call event, which occurs right before the LLM is invoked. So here we provide the output as before model call, and here we provide exactly message which agent has, basically the message provided by the user. Next, after model call, we will get event of type after model call event, and here we'll have exception. So if model fails, then we explain that there is issue with the model. We interrupt this function. If there is event stop response, basically LLM has stopped generating the message, we provide this stop message. If LLM has not generated any response, we will provide the message that response has been generated. Now that we have all these 5 callback functions defined, we have to attach these callback functions to the agent or subscribe these callback function to the events. We do so by using our agent instance, hooks, and using the method addCallback. And here we first provide message edit event, and then we provide the callback function. And we do so for all 5 functions. So I have slightly modified the code because previous code was trying to print out the query rather than defining that. Here we define query variables with the question, what is 25 times 7? And next, we print out the agent invocation using that query. So let's run the code. Okay, and now we can see something interesting. So here I'm defining that this is a Nova model, it is confirmed. And then we can see that once we provide the query, what is 25 times 7, the message is added by the user. This is exactly the message edit event. Next, before the model call, we define this query, and the model is providing us with its thinking. So it says to find the product of 25 and 7, I can use the calculator tool with the evaluate mode. So now the tool calculator is invoked, and after the model call, the model says to find the product, I can use the calculator with the evaluate mode. Basically, it repeats the same story. And now it is using the tool. So basically, it's invoking the tool. And after the tool invocation, this is a message by assistant thinking to find the product of 25 and 7. I can use the calculator tool with evaluator. So it's basically keep repeating this. Before the tool call event, it shows that the calculator tool has been selected. And in between these two lines, the tool is executed after the tool call event is generated after the tool execution. So the calculator tool provides us as a result a status success. So it was possible to successfully run the tool. Content of the tool response is text saying result is 175, and it shows the tool use, and this is the internal ID of the tool. So now the message is added to result, and before the model call, we have this message, product of 25 and 7 is 175. So after the model call, this message is not modified. So this is the output of the model. The product of 25 and 7 is 175. And finally, we are adding this message by assistant to the comment chart. And we are showing this message. This is the way how these event hooks are invoking callback functions and how we can intercept the actual events during the agent runtime. Now, before the summarize, I want to show another way of defining the callback functions and hooks. Here we have 5 callback functions, and we had to use agent.hooks.add callbacks 5 times as well, which is kind of cumbersome and can be very difficult to debug or test later, basically which introduces some repeating pattern. So how can we encapsulate it into a single class? For this purpose, we have the HooksRegistry class. So in this example, I am using all possible hook events, and we will use all these hook events in the HooksRegistry. So the code stays the same, except for this piece. We define a special class, AllHookLogger, and the first method it has is register hooks. So basically, we are using this registry, and we are registering or assigning to this registry all the possible hook events. Now, the callback functions, which we defined separately in the previous example, are becoming the method of this AllHookLogger class. And once you define the agent, you are now providing hooks, and you are providing AllHookLogger class as those hooks. So now you don't need to provide each and every callback function individually, and you don't need to write agent hooks add callbacks invocations each time. So this is a way you can basically encapsulate and put it into one place and make it more testable and more reusable code. So let me run this code. This time I will change the query and I will ask, what is the weather in Washington, DC? Let's run this. So here you can see we have intercepted some new events like agent initialization and before invocation event. Then we have the message edit event once we provide our query, what is the weather in Washington, DC. Then we have event before the model call, and the model is suggesting to use the get weather tool. Then we get this tool use message and tool use message again. Then we actually using the tool. This is before the tool invocation, and after the tool invocation, they get the response of tool used ID, status, and content, where we are getting the expected response of weather in Washington, DC is sunny and 72 Fahrenheit. Then we get the message edit with the tool result. And before the model invocation, this is exactly our message, which is generated by the tool. So after the model call, the message doesn't change. And finally, the message added to the chat. And after the event invocation, this message goes to the user. So here we illustrate the entire event cycle as it presented in this picture by AWS developer. So this concludes the AWS Strands hook, events, and callback functions. I hope you like this video. Please consider like and subscribe, and also tune up for more videos and check the previous videos from the series.